There we go. Alright, so we're going to continue where we left off last time, which was on the logical and relational operators. So that's stuff like and, or. Let's just go back here. So we have not, and, or, and there's also short circuit and short circuit or, but we're probably not going to go over that just because we don't use that too often. And then also some other stuff too. We have relational operators back here for less than or equal to, greater than or equal to, or not equal to. Alright, so we kind of covered everything, but I said that it would be better if we could actually go over kind of a more real-world example for using these relational and logical operators. So we've had a few of those so far with some of the examples that we've had in class. So stuff like a lot of the baseball examples. But we'll kind of go over it one more time, and we're going to use a little more complex example than what we've done so far for the baseball examples. So basically we're going to make this plot. Basically I'm just going to get the code. We're not going to go through the entire code because we know how to do a lot of that stuff now. We're just going to go over the part for the relational operators. So if you want, this code is available on Canvas. So it's on Canvas. You can go, it should be under today's page. So you can click on Otani data because you need the spreadsheet, and you can click on Otani code if you want to get the code. Or you can just follow along because, again, we're just going to go over one part of that code. So we're just going to go over this part basically. But I'll talk about the code in general before we kind of get to that part. Actually, let's get that back. Okay, so we wanted to make this plot here. So basically this was one of the games that Otani pitched this season, well, his only game. So basically what we're going to do is break this down by the amount of pitches that he threw per pitch type. So you can see here he threw a four-seam fastball like 52 times, 52 or 53. And then in red, we break it down for the percentage of swinging strikes. So for his fastball, about 10% of the time, that was a swinging strike. Curveball, he only threw 2 of those, so there weren't any swinging strikes there. But you get the idea. So we're just going to do that. So to do this, though, with the datasheet that we have, let's put that over there. Okay, yeah, so that's not going to be there. Let's open this up over here. Okay, so for our datasheet that we import from this code that we have, this is what it looks like. So remember, we want to get swinging strikes. So for that, we have to look at this column called description. And you'll see there's one that's called swinging strike. But we also need to get another one that's called swinging strike blocked. So we have to get both of those. By the way, I had to look this up because I've actually never seen it before. A swinging strike block just means that the ball went in the dirt and a batter swung and missed the ball. Okay, so we have to get these two things, swinging strike and swinging strike blocked. And we need to do this for, we have to match it up for those different pitch types that we have. So whether it's a fastball, a curveball, what else does he have? A split. So all of those in a slider. Okay, so we're going to do that. Alright, let's close out of this. So in the first part here, we're importing that spreadsheet, so we know how to do that. Next thing, we're converting pitch name to a string. So remember, we have to convert a lot of our columns from a cell array to a string array so we can use those logical and relational operators. Alright, and then we're doing the same thing with another column here. And then we want to find the unique pitches that Otani threw, so we're using our unique function. So, we've done this a few times before, so for your project, you would maybe do that for unique counties. I don't know if you have to do that, though, because I can't remember, I wrote the script for the project a while ago now, but for the population spreadsheet, I think it might just be the exact same amount of counties on that population spreadsheet and what's in the other spreadsheet with the vaccine data. Anyways, you might have to use the unique function, I can't remember, but we want to find the unique pitches that Otani threw, so we use the unique function, and then we get a four-seam fastball, curveball, slider, and split. Alright, so now we want to get our indices for when he threw each pitch. Okay, did I actually use this? No, I didn't use this here, but I guess at one point I wanted to find the indices for each pitch, so we'll just go over that too. So we want to make a cell array here, and oh yeah, because this is relevant now. So I got a question on, how to, like, what's the first thing that I would recommend to do for starting the project? And that would be getting the indices. So this is something that we do in a lot of our workshops that we've done. So, Lysandra, I'll get to your question in a sec. So this is one of the first things that we do for a lot of the workshops that we've done so far. And basically getting the indices for whatever you want to look at. So if it's, for counties or for baseball players, that we've done so far, you want to find the indices for whatever you want to kind of look at in the end. So getting the indices is probably one of the more important parts for the code. So you can get your indices, and for the project, if you have the indices for each county, then you can use those indices for each county, and you can then find the values for like the cumulative amount of vaccines that were given, or one dose, at least one dose per individual for a vaccine. So you can basically access those cells then, those rows. Alright, so here I just found the indices. Here we're finding the amount of pitches thrown per type. So I'm actually not using the indices in this part here, but basically I'm using our logical operator to kind of use that as almost indices in a way. So if I just did tp.pitch name equals pitch 1, we're going to get all these ones and zeros, and to find the amount of pitches that were pitch 1, which is a fastball, we use the sum operator, and then we can get how many pitches were fastballs. So in this case that was 52. Alright, now for the actual part that we want to really talk about for this exercise is the amount of swinging strikes or swinging strikes that were blocked, whatever they call that. That was swinging strike blocked. Okay, and we want to do this on a per pitch basis. So what we have to do, I'm gonna kind of combine logical operators again with sum, but for now let's actually delete this. So this is why I wish I was using my text editor again. Gotta go line by line like this. Alright. So if I run this for now, let's comment out the rest of the script. And if you guys forget to do that, to comment out multiple lines at once, you can highlight them and press Control R. Then to uncomment them, you do Control T. Okay, so here, let's take a look at this. So we want to find the amount of swinging strikes or swinging strikes blocked per pitch type. So let's try to get all this on one line. Here it is, kind of a lot to type out. So what we're doing is we're first finding when the pitch name was equal to a pitch 1, which in this case is a four-seam fastball. That's distracting. Okay, so we're finding when the pitch name is equal to four-seam fastball. And on top of that, then we have to find when the description column was equal to a swinging strike, or if it was equal to swinging strike blocked. Alright, so let's talk about this one more time. I'll restate it one more time. First thing, we want to find when pitch name was equal to four-seam fastball, basically. So remember, pitch 1, that's four-seam fastball. And so that's the first thing we have to satisfy, that it's a four-seam fastball. And then we're also telling Matlab that we need to satisfy that the description column needs to be equal to a swinging strike, or the description column needs to be equal to swinging strike blocked. Okay. And if I didn't have this part here, so let's comment out to these 3 lines. So if I didn't restate TP description right there, we'd actually get an error. So even though it might kind of seem like it should make sense at first, okay, let's delete that too. So you might think at first that, okay, this is telling Matlab that TP.description needs to be equal to swinging strike or swinging strike blocked. We get an error because it talks about this needs to be text or a pattern. So basically you can just put back in TP.description is equal to swinging strike blocked, and then that's going to run. What did I mess up here? Did I type it wrong? Line 36. It's going back here. What did I change? This isn't going like it should be going, because it ran before. Okay, now it's running. Maybe I had something kind of unbalanced here. But so to restate it, so we're finding when TP.pitchName was equal to forcing fastball. That's the first thing we have to satisfy. And on top of that, we need to satisfy TP.description needs to be equal to swinging strike, or TP.description needs to equal swinging strike blocked. And then we want to find the amount of times when that was true. So we use this sum function again. And then this is going to look like this. So that's the amount of times that there's a swinging strike for each pitch. And then we just find the percentage down here. This is something that's related to your project too. You have to find the percentage of vaccines given for a few of them. And you would do something like this, pretty simple. And then here's just the plot. We're not going to go over the plot because we know how to plot stuff now. One thing that might be useful is using this date string function. I don't know if we talked about that in class before, but that's going to convert a date time value to a string that can be printed in our plot. So, when we run this, then up top in our plot here, we get the date that's printed out. Okay, so Lissandro, I forgot to answer your question. The .data, that just takes me out of the current folder I'm in, and then I go into a folder that I have that's called data, and that's where I stored this data here. So you can see over here for my current window, I don't have that folder for my spreadsheet, or the file for my spreadsheet. It's actually back one folder, and then we go in a folder called data, and it's in there. Alright, so any questions on this before we get started on some new stuff? This might be something you want to take a look at too if you want. And again, the code is available on Canvas. Alright, so now we're going to go over some new stuff, which is going to be conditionals. Specifically, we're going to go over the if statement. Actually, let's get a title here. So I'm going to call this, you can call it whatever you want, but call it conditionals. Alright. So conditional statements, they're going to be pretty important for this class as well, and just in the future for when you write code. I think for loops are even more important personally, but conditional statements are also very important. So that's not going bigger like I wanted. Okay, so in everyday life, we use conditional statements to make decisions whether you actually realize it or not, but as an example, if I get an A on my exam, like you might think this to yourself, if I get an A on my exam, I'm going to drink beer. Else, if I get a B on my exam, I'm going to have ice cream. Otherwise, I'm just going to cry. So we can kind of break this down in Matlab to do the same kind of decision making for us. So the kind of pseudocode that we have here in Matlab is if I get an A on my exam, that's one line, then I'm going to drink beer. Else, if I get a B on my exam, I will have ice cream. Otherwise, so if none of these are met or satisfied, so if I don't get an A and I don't get a B, if I get a C, D, or F, I'm going to just cry. And then we put a period at the end. So we're going to use Matlab conditional statements to write a program that's very similar in structure to what's above. And we're going to write this program by using conditional statements that have if, else, and else if. Okay, so we're going to, of course, go over all of those. And at the end of this, we need to have an end statement. So that's going to tell Matlab I'm done with this kind of block of code for this conditional statement. Okay, so the basic structure for the most simple if statement here is if some logical expression is met, then do some statements. So if some logical expression is satisfied, then we're going to carry out these statements here. And, oh boy, people are being loud right now. So if it's not satisfied, then nothing's going to happen. Okay, so keep in mind that this right here, it's going to be some logical expression. So we're going to get a logical result of 1, that'll be true, or 0, that's going to be false. So if it's true, we have a logical 1, then we're going to carry out these statements. If it's false, a logical 0, then nothing's going to happen unless we later have an else statement, but we're going to go over that soon enough. Okay, we're going to start out simple here. Okay, so let's do some basic ones. Make this smaller and put this over here. Alright. So I'll call this basic if statement. Okay, so we're going to say, first off, we're going to define a variable called, let's do A actually. So we'll do A equals 25. And then we'll say if A is greater than 5, so that's a logical statement right there, or expression. So if A is greater than 25, then let's calculate the, let's do, the square root of A. So we'll say if A is greater than 5, then B is going to be equal to the square root of A. And then we need to have our end statement at the end. All right, so if I run this right now, let's see what we get. We get an answer of B equals 5. So the first thing that this code block does is it looks at this logical expression here, A greater than 5. So if we go in our command window here and I type in A greater than 5, we get an answer that's a logical 1. So that means that, yeah, that's true. A is greater than 5. So 25, yeah, that's greater than 5. So because that logical expression was true, we're going to then carry out our statements here, which in this case is B is going to be assigned to the square root of A. So square root of 25 is 5. So we get B equals 5. Alright, so any questions on this part? We're going to expand on it, but does everyone get this basic block of code? Alright, so let's say that Yep, we're going to do a lot of examples. Okay, so let's say that A was not greater than 5. So let's say A was 4 this time. So if I have A equals 4, let's comment this out for now. So if A is greater than 4, if I run the logical expression that we have, which is A greater than 5, I need to run this up here. Okay, so A greater than 5. Now we get an answer of logical 0 because 4 is not greater than 5. All right, let's comment this or uncomment it. Okay, so now if I run this, nothing happens this time. So Matlab first ran this logical expression here, a greater than 5, that had a logical answer of 0, because 4 is not greater than 5. So because that wasn't satisfied, we don't carry this out. Remember, we only carry out these statements if this logical expression was true. Okay, so if I go back a slide, we see here that the statements are ran only if the logical expression is true. They should say if. Alright, so yeah, no ice cream. Yeah, or no beer. That's really the sad thing. Okay, so again, because this wasn't true, because 4 was not greater than 5, we did not carry out this logical, or this statement here. Is there a question? Like your mic is on and echoing. Okay. Alright, so let's go over some more now. Alright, so now we're going to nest if statements. Okay, so it might look a little complex here, but I assure you it's not. We're going to break it down. But before we do that, basically we can nest these if statements here. So I'll say if logical expression 1, if that's true, we're going to carry out this statement group 1. And then we can move on to a whole new logical expression. So we can say if logical expression 2, if that is true, then we can carry out this second statement. And later on, we're going to make this actually more compact. But for now, we're just going to keep it simple to where we can have these two different logical expressions that can carry out these different statements. Let's make a comment here. Let me change my color scheme to the default. Then I gotta go here. Apply. Alright. Alright, so let's say A equals 20, and then we'll say B equals 5, or negative 5. And we'll say if A is greater than or equal to 0. Also, you'll see that when after I go to my new line, so first I'm on this line here. Once I press enter, Matlab should automatically indent our next line. So it does that automatic indentation for better readability. So that's the convention too. So if you don't indent it, basically you're going to be thought of as a weirdo. So don't do that. Just leave it indented like this, and it's going to help with the readability, especially when you use these nested if statements too, and for loops later on. So we have if A is greater than or equal to 0, then let's calculate, or let's make this new variable called C, and we'll say C is equal to A plus 5. So let's just end this for now. Go up here. Is that my phone? Yeah, that's my phone. Sorry. Okay, so if A is greater than or equal to 0, we're going to calculate C is equal to A plus 5. Alright, so A, that's greater than or equal to 0, we have 20, so we should expect our output C to be equal to 25. And that's what we get. So next thing, let's go down here, and then I can nest an if statement here. So this is going to be just a whole new logical expression here. So I'm going to say if B is less than 0, D is equal to square root of C, and I'll say end, and you see that also aligned that end statement automatically for us for this block of code right there. So really nice that it does that. Most programming languages aren't going to do that though, so that's good. Okay, so the first one we have is if A is greater than or equal to 0, we're going to say that C is equal to A plus 5. Then here we're looking at a whole new basically logical expression that we're making. So now we're saying if B is less than 0, then we're going to calculate or assign D is equal to the square root of C. So then it's related on this part here. So let's run this right now and see what we get. So the first one is 25. That's what we did with our very basic one that we just made. So let's do it again. I'm going to repeat myself for a lot of this stuff just to make sure that we're very clear on what's happening. So we have if a is greater than or equal to 0, make a variable called c, where that is equal to a plus 5. So 20 is greater than 0, so we have c is equal to 20 plus 5. We get an answer of c equals 25. Then we move on to our next if statement, which is if b is less than 0. Here we have b equals negative 5, so that's going to be true. So we are then going to carry out this statement here, which is d is then going to be equal to the square root of c. So the square root of c here of 25, that's going to be 5. We get an answer of d equals 5. Alright, so let's change some stuff here and see how it affects this block of code. Let's make b equal to 1. Alright, let's run this now. And now all we get is c equals 25. So let's go through it. We have a. If a is greater than or equal to 0. So same thing. 20, that's still the same number. 20 is greater than 0. So we do c is equal to 20 plus 5. That's 25. Now we go into the next if statement. If b is less than 0, 1 is not less than 0, so we are not going to carry out this if statement, or this statement right there. Okay, it's just going to terminate. Alright, let's change this up again. Let's say a is negative 1. Now if I run that, nothing happens at all. Okay, so when we first check if a is greater than or equal to 0. Negative 1 is not greater than or equal to 0. So we're not going to do anything there. Let's change this to, let's also then change, I don't know, b to, let's say, 5. Okay, let's run that. Still, nothing is going to happen. Actually, let me make this negative 5. Okay, so still nothing is going to happen. So first thing we check is if a is greater than or equal to 0, negative 1, that's less than 0. And because of that, we're just going to terminate automatically. Even though in this nested if statement, we have if b is less than 0, well, negative 5, that's less than 0. But we don't even get to this block of code right here for this nested if statement because this first logical expression up here was not satisfied. Okay, so this is a nested if statement. So this first statement here, something needs to be done. This wasn't satisfied, so we can carry out the rest of this block of code. All right, any questions on this part? Maybe let's modify some of this stuff a little more so we can take a look at it a bit more. Man, my nose is itching. Okay, cool. So we'll do like 1 or 2 more just to understand it. I know it might, for a lot of this stuff that we're learning now, it's maybe a bit to take in at first, but once you break it down line by line, you should get it. You're not going to use this part on the project. Well, you could if you want, but if statements aren't required for the first project. Basically, for the first project, you've learned everything that you need to learn so far, unless it's like a really small thing like that date string function that we just talked about in that example, but it'll be something really small like that. And also, it's on the document, but I just want to restate that you can't use for loops for the first project because I want you to suffer. I don't really, but I want you to basically get a good appreciation on the second project when we actually use for loops, because again, that's going to save a lot of time. That's why I only have the top 5 populous counties, though, to be a little nicer there. Okay, let's go to this example again. Let's say A is, let's say, I don't know, 36. Okay, that's not going to be a nice number. Whatever, I'm going to leave it. Okay, and then let's say B is, let's say, 0. Let's run this. So we're checking if A is greater than or equal to 0. 36 is greater than that, so that's good. we're going to move on, and we're going to calculate C is equal to A plus 5, so that's 36 plus 5. C equals 41. All right, now we're going to move on to the next one. So let's check. Is 0 less than 0? No, so we can't move on. We're just going to terminate right there. Let's change this. Let's say if A is greater than or equal to, I don't know, let's say 10. And let's change this down here to, I don't know, 5. Let's run this again. So 36, that is greater than 10. So we're going to calculate C. That's 36 plus 5. We get 41. Now we're going to move on to this if statement. So is 0 less than 5? Yes, that's true. So we're going to carry out these statements here, which is going to be the square root of C, which we already calculated, which was 41. So we calculate the square root of 41. That's 6.4. All right, we can even add on, let's say plus B here. So let's run this again. Now it's going to be a little different. Well, B is 0, so let's change that. Let's do 1 here. So if A is greater than or equal to 10, this part is the same. 36 is greater than 10. We're going to carry out C. That's 36 plus 5. C equals 41. We're going to go into our next if statement. So is 1 less than 5? Yes, that's true. So we're going to go to these statements here and carry them out. So we have the square root of C. So that's the square root of 41. And then we're also then going to add B here, which was 1. Okay, so we get this answer of 7.4. All right, everyone good on this so far? In general, we're going to be still going over a lot of these, the basic kind of knowledge or application of these if statements. We're just going to add on some other things too. So if you want more examples, there's going to be a lot more. Find it cool? Yeah, that's good, because this also helps save a lot of work too. I probably don't use them as often. Well, I know I don't. I don't use these as often as for loops, but they certainly help save time too. And you can use them with for loops, which we'll see later on. All right. So now we're going to add on the else statement. So far, if a logical expression wasn't satisfied, it just terminated that part of the code. So remember, if we change this to, let's change this to 6 now. So the first thing is we have 36 is greater than 10, so that part's the same. So we calculate C equals 36 plus 5, that's 41. Now we move on to this one. But now we have 6 greater than 5. That's not true. Less than. So we check, is 6 less than 5? That's not true. So because that wasn't satisfied, we did not carry out this statement here. It just terminated. It just stopped our script right there. But we can add in this else statement here to then tell Matlab to do something else if a logical expression wasn't satisfied. So let's make this bigger. I know my video went away for a sec. So the structure for using an else statement is going to be as follows here. So just like we just went over, we still have if logical expression. If that is satisfied, we're going to carry out this statement group 1. But if it's not satisfied, if this logical expression is not satisfied, then we're going to use our else statement, which says, if this logical expression is not satisfied, then we're going to carry out this statement group 2. Okay, and basically what I just said is, written out right here. All right, so let's do a few examples for this now. Oh yeah, little flowchart if you want that. I actually think for these things, the flowchart is useful. I don't use flowcharts for, my whole script, but for learning this if statement, else statement, and later on else if, I think these flowcharts are useful. So basically we have if our logical expression, if that's true, we're going to carry out that statement group. If this logical expression is not true, then we use our else statement and we carry out this statement group 2, and then we terminate that part of the code. so let's go through these examples here. So call this else statement. Alright, so here, oh yeah, let me suppress my code up here. For a lot of these examples, I'm not going to suppress the code in the beginning because I want to show you guys the output in the command window, but I need to remember to suppress them now. Okay, so let's do x equals 2, and then let's say if x is, oh yeah, I just remembered. If you're wondering how we can use these with like vectors, we're going to do that in a bit. So for now, we're just using scalars. We have x equals 2, not x is equal to some vector. Okay, so let's say if x is greater than 10, then we're going to carry out this statement called y is equal to x squared. And if that is not met, so if x is not greater than 10, then we're going to use our else statement now. And we're going to say, then I want you to calculate z equals x cubed. And then we need to terminate this if statement, so we're going to put end at the very end. Alright, so before we run this code, let's think about it. So we have x equals 2. So we're going to check this logical expression right here, x greater than 10. Well, that's not true. 2 is not greater than 10. So we're not going to carry this out. But we have our else statement here. So Matlab is going to see that we have this else statement. And it's going to then carry out this statement right here, which is 2 cubed. So we should get an answer of 8. Oh, in my script here, I flipped them, the exercises. Doesn't matter. Let's run it. We get an answer of 8. So I'll explain it one more time. So first thing Matlab looks at is x greater than 10. So it's doing x greater than 10. That's a logical 0 because 2 is not greater than 10. So because of that, we do not carry out this line of code. But we have an else statement here, which we have. So basically, if this is not satisfied, Matlab is then going to carry out this statement here, which is, in this case, 2 cubed, which is an answer of 8. Alright, so let's change this now. Let's go to x less than 10. So now we're going to check if 2 is less than 10, which yes, that is true. So this time we're just going to carry out y equals 2 squared, which is going to be 4. So because this part is true, we're actually not even going to look at this part because we already satisfied our logical expression. So if I run this, all we're going to get now is y equals 4. Alright, does that part make sense? Yeah. Okay. Alright, so I don't think we've covered this before. It's always, I kind of like mix semesters when I teach some stuff. So I don't think we've gone over the display command before, but we're going to go over it now. It's really simple. So we're going to use the display command as one of the statements for our else statement. Okay, so here in this line of code, or this block of code rather, we have x equals to 12. Then we say if x is greater than 10, we're going to carry out the statement y equals x squared. If that is not met, so if x is not greater than 10, we're going to display the line number is less than 10. So that'll be displayed in our command window. Alright, let's do this. And where I'm getting at, well, I guess you'll see. One of the first things is we're going to build up to using techniques to not hard code. And then later on, we're also going to go over how we really need to be careful with how we set up our if statements. But we'll get there. Okay, so let's say, alright, let's suppress this stuff up here. Okay, so we're going to have x equals 12. And we're going to have if x is greater than 10, we're going to carry out y equals x squared. If x is not greater than 10, we're going to use our else statement now to carry out this display command. So the display command is disp, and then in parentheses, we're going to have single quotes, and we're going to say number is less than 10. And because we have an if statement, we need to close it out with an end statement. Alright, so if I run this right now, we get an answer of 144. So remember, we look at if x is greater than 10, 12 is greater than 10, so we're going to carry out y equals x squared, which is 12 squared, 144. Alright, let's change this to 8. So now if I run this, x is not greater than 10, so 8 is not greater than 10, so we don't carry this line out, but we have our else statement, so then we carry out this line. And then we see in our command window, we get that line that says number is less than 10. I think you can actually have double quotes. Let's check. Yeah, so you can have double quotes too, but the convention is single quotes, but I guess either way works. So sometimes it does work like that, and other times it doesn't, so I don't know, gotta be careful with that. Alright, so I think that part is pretty simple, but we're gonna build off of that now. So now, like I was mentioning, we're gonna build off of this so we can start to use techniques that we've used before for some of the workshops to not hard code. So right now this statement just says number is less than 10, which, you know, I guess is okay, but I actually want this to display whatever that number was if it was less than 10. So in this case, I would want it to say 8 is less than 10. So let's modify this so we can do that. So we're going to say display. And the formatting for this part is kind of like our title that we use for our graphs. So I want to do number to string. So I'm going to use num to string. We need our quotes. So we have num to string. And we're going to put in x. Okay, because I want to convert this number x into a string that can be printed. Okay, and then we're going to say, actually I shouldn't have my quote here. So we're going to say is less than, and then we're going to have num to string again. And this time we're going to say target. Also, I know I don't have this formatted exactly correct yet, don't worry. So we're also going to add in a new line here called target equals 10. And now let's substitute this part here to be target. And there we go. So if I run this, it's not going to run right now. It says that we need to check for our brackets. So if you remember when we made our titles and some of our plots and we used these functions like num to string or date string, something like that, we actually need to wrap all of this in square brackets. Okay, now if I run this, let's suppress that part. So now if I run this, we get 8 is less than 10. Alright, so now in our display line here, we don't need to type out the specific number for x, and we don't need to type out the specific number for our target that we have. So let's change some of this. Let's say we have 18. That's going to calculate the square of that this time, because 18 is greater than target. So let's make this, I don't know, 4. We'll run that. So 4 is not greater than 10, so this line is not going to be executed. We're going to move on to this statement, which is going to display 4 is less than 10. Oh, okay, yeah, so there's a question, why is my number so close to my words? I think you mean, like this part here. So that's why I have this space here. So if I don't have those two spaces, it's going to format it like this. So we actually have to add in a space in the beginning there, and then a space at the end. Is that what you were talking about? Yeah, okay, cool. So yeah, you just got to add in those spaces there. And same thing with your title for your plots. If you're doing stuff like this, like num to string, you need to make sure that you have that space there too. All right, let's change target, I don't know, to 5. Let's run that. And again, it's updated, so we don't need to type out or change anything on this line here. It's just going to update dynamically. All right. So same kind of thing that we've been doing so far. We just added in some, I guess, fancy stuff for this display line. Okay, now we're going to talk about the else if statement. Alright, so this is going to give us basically the most general form for the if conditional. So this is basically going to cover everything that we can have for the if statement. So we're going to have if logical expression 1, if that is met, we're going to carry out statement group 1. And then we have this function here, else if. So this is going to be some whole other condition that we can meet. So we have else if logical expression 2. If that is met, then we're going to carry out statement group 2. And then if none of these two are met, we're going to have our else statement, and that's going to say carry out statement group 3. So remember before we had that nested if statement here, and it's a little long, so we can be more compact by using this else if statement instead. And yeah, and so we actually have a line like that as well, or an exercise that's similar to that. All right, so let's talk about this, I guess, one more time. We have if logical expression 1, if that is true, we're going to carry out this statement group here. And then we have a whole other logical expression 2. If that is met, then we're going to carry out this statement group here. If none of these logical expressions are met, we're going to carry out statement group 3. Oh yeah, also take note that this else if statement, it has to go before the else statement because we're checking if we can meet some other logical expression. And else is always going to be at the end because that's going to say if none of the above expressions were met, then we're going to carry out this other statement down at the end. All right, let's put this here. Flowchart again if you want. So if our logical expression 1, if that first one is met, we're going to carry that out. If it's not met, we're going to go to our second logical expression now. And if that is true, we're going to carry out that statement. If that is not met, we're going to carry out some other statement. Jeez, I got like a lump in my throat. All right, let's do an example. Suppress that. Oh yeah, you know what? So yeah, I can suppress that too. No, I can't. That's the thing. So I can't suppress this display command. So I'm actually just going to comment all of this out for now, just so I'm not distracted by that. All right. So else if exercise 1. So we're going to do this the long way, the long way that I call it, because we're typing this out in a bit of a repetitive fashion. Yeah, so sorry. If you're on a Mac, I need to remember not to cough right in the mic. If you're on a Mac, if you want to do something like Control R, I think it's Command /. So try that. And then to uncomment stuff, it's still Command T on a Mac. Alright, so else if. So we have z equals 9. Did that work, Lissandro, by the way? Command /. Okay, cool. Alright, so we have if z is greater than or equal to 5, then we're going to carry out, if that statement is true or that logical expression is true, we're going to carry out r equals z squared. And then I'm saying else if z is less than 5, then we're going to carry out some other statement called s equals square root of c. All right, and then we need to close this out. So we have one if statement right there. We need to have end, and we have one more if statement up here. So we need to close that out with end as well. So we're gonna first check if z is greater than or equal to 5. So if that is true, we're gonna carry this out. If that's not true, we go to our else statement here. And then Matlab is going to see that we have a new if statement, and that's going to say if x is less than 5, we're going to carry out s, or did I say s there? If x is less than 5, we're going to carry out s equals square root of z. Alright, so if I run this now, we get r equals 4. Uh-oh, my camera died, sorry guys. I swear I charged this up all the way. If my battery's already that crap, then that's bad. I'm gonna close this out.
Is it like a wireless camera or something like that? You just link up the Zoom?
It's actually wired up to my computer, but it's like my DSLR, so I need batteries for it, and I guess it died.
Oh, okay.
Kind of insane though. Okay, so let's break this down one more time. So actually let's run it and then we'll see what we have. So we have an answer of r equals 4. So on this line here, we check if z is greater than or equal to 5. So 9 is greater than 5. So we're going to carry out, oh, what? Oh, oops. That needs to be z. There we go. I was very confused. Okay, so we have 9 is greater than 5, so we're going to carry out this line here, which is r equals z squared. So we have 9 squared, that's 81. So now let's put instead 4. Let's run that. So z is equal to 4. So 4 is not greater than or equal to 5. So we're not going to run this line right here. We're going to move on to else. In this case, we have a whole new if statement, which says if x is less than 5, so 4 is less than 5, we're going to carry out s equals the square root of z, which is the square root of 4, so we get s equals 2. So, you could tell that we didn't even need all of this, right? We could just say else carry out s equals square root of z. So if I was going to delete this stuff like this, you see we get that same answer. I'm going to control Z this though. Alright, so let's be more compact right now, and we're going to use our else if statement. And you'll still note that we don't need to say else if for the next exercise. We can still say else and it would be fine. I'll show you. Okay, so else if exercise 2. So the more compact way to do the above, let's say z equals 9. If z is greater than or equal to 5, we're going to say r equals z squared. And now we're going to say on one line here, else if z is less than 5, we're going to carry out s equals square root of z. And then we have our one if statement here. So now we only need one end statement right there. If I run this, do I not have one of these? Okay, so we have if, where's my r? Right there. Okay, oh, I need to comment this out. There we go. Jeez. Okay, so we first check if z is greater than or equal to 5, which is true. So we're going to carry out r equals z squared. That's 9 squared. We get 81. So we don't even need to look at this logical expression right here. So let's now instead make this 4, and it's going to be the same thing, or the same result that we saw above. So 4 is not greater than or equal to 5, so we don't carry this out. We move on to this else if statement, which says, basically, else if this is not met, then we're going to say if z is less than 5, we're going to carry out s equals square root of z. So we have the square root of 4, that's 2. But again, you might be looking at this and be like, well, yeah, I could have just done this, and that would be the same, which is true. But the else if command is good if we want to have two things here and then an else statement down here for if these two different logical expressions were not met. We could have this else statement down here. And we could have a ton and a ton and a ton and a ton of else if statements. So I'll show you what I mean by this and this one right here. Let's suppress those. So else if exercise 3. Okay, so let's say m is equal to 6. We're going to say if m is greater than 10, then we're going to carry out this statement. T1 is equal to the square root of m. Okay, then we're going to say else if m is greater than or equal to 5, then we're going to carry out this statement T2 is equal to m squared. Jeez, keep doing this. Okay, and then we're going to say else if none of these logical expressions were met, so if m greater than 10 and m greater than or equal to 5, if neither of those were met, we're going to say else carry out T3 is equal to m. Then we're going to end it. Alright, so basically what this is saying, and reference the slides too if you'd like. We're first checking if m is greater than 10. If that's not met, we're going to move on to here, which says else if m greater than or equal to 5. So really, this is now checking if m is in between 5 and 10. You can see that in our slides as well. And then if neither of these are met, so basically if we're not in between 5 to 10, then we're going to carry out T3 is equal to m. Alright, so let's run this now and we'll see what we get. Alright, so we're first going to check if m is greater than 10. 6 is not greater than 10, so we're not going to carry out this line here. We're going to move on to else if m is greater than or equal to 5. So 6 is greater than 5. So because that's true, we're going to carry out this statement here, which is 6 squared, that equals 36. If I do 5, we're going to get the same kind of thing. So 5 is not greater than 10, so we can't carry this out. We're going to move on to this line here. And 5 is equal to 5, so that's true. So we're going to carry this out right here, which is 5 squared. Alright, let's do 11. So, is 11 greater than 10? That's true, so we're going to carry out the square root of 11, which is 3.31. Let's do 25, so it's nicer. There we go, so T1 equals 5. Now let's say we have 3. So, is 3 greater than 10? No, so we can't carry this out. Is 3 greater than or equal to 5? No, so we can't carry this out. So because neither of these logical expressions was true, we're going to move on to this else statement now, which says T3 is going to be equal to m, which is 3. Alright, does this make sense to everyone? Okay. Oh man, I was checking my camera. I guess the battery really is dead. I don't know how. That's disappointing. Now I gotta buy more. Alright, so now we're on to taking a note of code structure. We're going to do a more complex example, by the way, later on. Here. You know what, actually, I think it would make more sense to do it right now. Alright, so let's take a look at this more complex, nested example with a lot of statements, right? So we're going to be kind of doing the whole enchilada here. We're going to be doing a lot of things in one block of code. Big ol' nested exercise. Okay, so we have a ton of stuff here. Don't worry about all this stuff up top. But basically, that's the you know, all the stuff that we're going to do. So let's say a equals 5. And we'll say if a is greater than 0, then we're going to carry out b equals a squared. And then in a nested statement, we're going to say if b is greater than 20. So we're going off at this now. So if b is greater than 20, we're going to calculate c equals the square root of b plus 2. Else if, so if b is not greater than 20, we're going to say else if b is greater than or equal to 10. So just like our last example, this is now saying if we're basically somewhere in between 10 and 20, then we're going to calculate c is equal to the square root of b plus 4. Dang it, I did it again. Okay, so then we're going to say else if this was not met, and if this was not met, then we're going to carry out c is equal to b. Okay, so here is one if statement, so I got to close it out with and. And then we're going to say here else if, so now we're looking back at this statement up here for a. We're going to say else if, so basically if a was not greater than 0, we're going to say else if a is greater than or equal to -5. So basically if we're in between -5 and 0, then we're going to carry out b equals a cubed. Did it again. Okay, so now we're saying if this was not met and if this was not met, so basically if we're not in between -5 to 0, we're going to say else calculate b equals a. Alright, so there's a lot of things going on there. Kind of just went through it now, but let's go through it more visually. Alright, let's run this. Let's pull this up as well. Okay. Let me get that too. Alright, so first thing that we're looking at is right here. If a is greater than 0. So that's true. A is 5, so 5 is greater than 0. So we're going to move on to calculate b here. So b is going to be equal to 5 squared. So we get b equals 25. And now we're in this nested if statement right here. So we have if b is greater than 20, calculate c equals the square root of b plus 2. Let's call this, I don't know. Yeah, that'll be c. Let's say this is d and this is e. And this down here, we'll call this f. And this will be g. Okay, so we have, so we're here now. So we have basically, is 25, yep, is 25 greater than 20? That's true. So we are then going to calculate c equals the square root of b, which is the square root of 25. So we have 5 plus 2, that's 7. So we get c equals 7. So we met both of these now. This was true, so we carried out b. And then this was true, so we carried out c. And so we're done. We met all of our logical expressions. So we're done with this block of code. Alright, so now let's just change the stuff a bit. And this is probably where we're going to end off today, actually. So let's change a here. Also, if I want to comment out this line, I don't need to click here, or I don't need to do this. I can just go on the line and just do Control R, and that'll comment it out too. Alright, let's do a equals 4. So, in the slides, I actually showed the answers that we're going to get for both b and c for all of these other things that we're going to test out. So let's do a equals 4. Alright, first thing we check is 4 greater than 0. Yep, that's true. So we're going to carry out b equals a squared. So that's b equals 4 squared. So b equals 16. That's what we get. Now we're checking, is 16 greater than 20? No, it's not. So we can't carry this line out. So we're going to move on to else if b greater than or equal to 10. Is 16 greater than or equal to 10? That's true. Now we're going to calculate the square root of 16 as 4, plus 4 is 8, so we get d equals 8. Alright, cool. Comment that out. Let's move on to a equals 3. Let's run this now. Right, so is 3 greater than 0? Yeah. So we're going to move on to b equals a squared, so that's 9. So we have b equals 9. That's what we see here. Okay, so is 9 greater than 20? No, that's not true, so I can't carry this out. We're going to move on to this line here. Is 9 greater than or equal to 10? Nope, not true, so we're not going to carry out this line. We're going to move on to our else statement now, because this logical expression wasn't true, and this logical expression wasn't true. So we're moving on to our else statement, which is e is simply equal to b, so e equals 9 because b equals 9. Alright, let's comment that out now. Let's move on to our next one, a equals 2. Okay, so is 2 greater than 0? Yeah. Okay, so b equals a squared. That's it's gonna be 4. Basically, it's the same thing that we just did actually. So I don't know why I kept this one in. So 4 is not greater than 20. We can't carry this out. 4 is not greater than or equal to 10. We can't carry this out. So we just have e equals b, which is 4. Alright, let's instead change this to -3. Alright, so first thing we're going to check is a greater than 0. So is -3 greater than 0? No, that's not true. So because it's not true, we're not going to carry out any of this stuff that's nested here. So none of that's going to be carried out because, again, this logical expression was not true. So, we're kind of basically looking at here and then the rest down here. If this was not true. So remember, because this logical expression was not true, we can't carry out any of this stuff. So we're going to move on to this else if statement down here. So is -3 greater than or equal to -5? That's true, so now we're going to carry out this line. So we have a or f equals -3 cubed, which is going to be -27. Alright, and then we got one more, which is a equals -6. Basically to cover every single statement here. So is -6 greater than 0? No, that's not true. So we can't carry out any of this stuff here. We're going to move on to this one, this logical expression here. Is -6 greater than or equal to -5? No. So we can't carry this out. We're going to move on to the else statement, which is just g is equal to a. So we have g equals -6. Alright, so we basically went through every single possibility for this block of code to cover it all, right? So are there any questions on this part? No? Okay, cool. If you guys are following along, that's good. I think hopefully it's simple so far. Alright, so now we're going to go to the part in the last few minutes that we have here for taking note of code structure. Now before we do that, I'm going to ask again, okay? I'm going to repeat myself, but does everyone get it? If you get it, put it in the chat. If you don't get it, put that in the chat. It's okay. You're not going to, offend me if you don't get it. Well, I'll be sad, but okay, cool. Okay, alright, cool. Alright, so let's move on in the last few minutes that we have. So we're not going to be able to get through all of this here, but we're going to talk about taking note of the code structure that we have. Structure 01. Alright, so let's say we have, oh boy. I'm not going to suppress each line, I'm just going to comment this out. Okay. So taking note of code structure. Oh, yeah, I forgot this one. Just do that. we have x equals -4. And then we're going to write a very simple if statement now compared to what we just did. We're going to say if x is less than 0, display some values are negative. And then we're going to say end. Oops. Let's do that. So -4 is less than 0, so that's true. So we're going to display some values are negative. So very simple compared to what we just did. Right, so let's move on here to now, instead of just having a scalar for x, we're going to have a vector. So let's say x equals -4, 2, and 5. So if I run this now nothing shows up at all. So we want to keep in mind that this is a logical expression. So if I type in the command window x less than 0, we get not just a logical scalar answer, we get a logical array. So it's going through each element here in x, and it's checking whether that number is less than 0. So -4, that's less than 0, so we get a logical 1. And then 2 and 5, they're greater than 0, so we get a logical 0 for both of those. So in order for this line to actually run, basically this entire logical array has to be true. So all of that has to be true in order to display this. Because not all of them were true, that line wasn't displayed. So if I was going to change this to all like negatives, now all of that is true. So now it's actually going to display our line here. So if I do x less than 0 here, all of them are true. So we can run that. So we need to be careful to make sure what, to make sure that we know what our code is doing. So in this case, that entire logical array had to be true to display this. Now you might be thinking, what if I want to do it, really element by element? So basically, if we could run our code here and have it basically say -4 is negative, and then maybe say 2 is not negative and 5 is not negative, kind of do it that way. In that case, we'd actually have to use a loop as well. So we're going to get to that next class. But, we don't have time here. And we're actually going to expand a bit more on this idea of making sure that we know what's going on in a few more slides. All right, but we're out of time. So we're going to pick up on this next time. You guys, we're going to have a quiz next Wednesday. So I'll make some homework. I guess I got to make it today now. So I'll make some homework today. And it'll be due next Wednesday. I'll post the solutions on the weekend. But yeah, quiz will be next Wednesday, basically on what we went over last class and today. So logical and relational operators and the if conditional. Right, so I'll get the homework up sometime today. It's probably going to take a while to make though, but it'll be up. All right, so that's it. I'm a minute late, but whatever. I'll see you guys on Monday, so have a good weekend and make sure you work on the project too.
Thank you, Professor. Have a nice day.
Thanks, you too. Thanks, guys.